So we are going to be solving this guy now. So I want you to get along with me. Okay? Now, so we are going to solve this example 2 now. So let's solve the problem. So 250 centimeters of a gas A diffused through a small hole in 35 seconds. The same volume of oxygen under the same condition diffused in 48 seconds. Calculate the relative molecular mass of A. Let's get it started. So let's calculate the molecular mass of A. We don't know the gas A actually, that's why it is unknown. So we're having what? Gas what? Gas A, and this is unknown gas, and we are having oxygen gas. This is known gas. This is unknown gas. Okay. All right. So now here we have that 250 centimeter cube of a gas A diffused through a small hole in what? 35 seconds. Time rate for this to diffuse is 25 seconds. All right. So the same volume of oxygen under same condition. What happened to it? Under the same condition, diffuse in 48 seconds. So the time for oxygen is what? 48 seconds. So we don't know the relative molecular mass of this because the gas is unknown, but we should know the relative molecular mass of oxygen. Relative molecular mass of oxygen gas, that will be O2. All right. So literally our oxygen is always 16. The mass number of our oxygen is always 16. So since it's 16, then we have 2 times 16. So it's going to be giving us what? 32. Okay, so we're having 32 grams. All right. At this junction, so it is easy for us to say that, you know, if you remember when I was proving the equation, I said T2 over T1 is equals to the square root of M2 over M1, if you remember very well. So which means that this one is for the second, you can see 2 years for the second gas, and this is for the first gas. So relating it with what we have here, so we are going to be having T for oxygen gas over T for the unknown gas, which is equals to the square root of relative molecular mass for the oxygen gas over relative molecular mass for the unknown gas. Alright, so now what are we having for this? We are having CO2. Time of this, we are having 48 divided by 25. Is it? We are having 35. 48 divided by 35. This is 35, not 25. Alright, so equals to the square root of what are we having for this? We are having 32 divided by the unknown relative molecular mass of gas. Alright, so at this junction, what do we have? We are having that 3, we can just square both sides. It becomes 32 over MA is equals to 48 over 35 squared. By the time you square both sides, this one is gone. Alright, so now 48 times 48. So this one is going to give us 2304 over 35 times 35, 1225, 32 over MA. So which implies that our M of A is equals to 32 times 1225 divided by 2304. So 1225 times 32 divided by 2304. So we are ending up to be having what? MA equals to what? 17.0138, which is approximately 17 grams. So our relative molecular mass of the unknown gas is at the later end 17 grams. So I hope, but most times I hope you understand this, but most times, oh sorry, the unit is not necessary. The relative molecular mass is not necessary, so you can just leave it at 17.0. So that is our final answer for this question. Bye bye.